Hello and welcome to our tutorial. So in this tutorial we're going to have a look at rendering in Blender, and specifically we're going to look at rendering in the Eevee render engine. So this is our default setup in Blender, and we can press 0 here over the numpad and look through the camera. And if we want to render what we can see here, we can render an image, and that's what we get. So we can see it's a certain size, it's lit a certain way, the background is grey, and we can save this image if we want. So we can go image, save as, and it's at the moment set to be a PNG. We can change the image format and then all of the attributes that go with it. So Blender will create an image or a movie from basically what the camera can see in the viewport. So we're just going to kind of walk through how to render and what affects rendering and how slow and fast it is and what we can expect to encounter as we render out images of characters, etc. So let's start with this tab here, which is the output, as you can see there, for Blender. So first thing is, by default it sets to 1920 by 1080, which is the resolution of high definition video. So if you wanted to have ultra high definition, so like a 4K kind of output, although it's not quite 4K, you just multiply both of those numbers by 2 and you would have a UHD image. But in reality you can put in any numbers you want. So you could put in the resolution for an A3 page or an A4 page. At the moment it's obviously wider than it is taller, but that's you can change that pretty quickly just by mucking around with the resolution. So I'm going to leave it at 1920 by 1080 for now, which is HD. This here is a very handy tool if you were trying to do a preview of something, particularly something big. You can set it to say 50%. And it'll render 50% of the horizontal, 50% of the vertical. So it's at 50%, it's actually giving you a quarter size image. So if we render that, this is only quarter HD. So if you're trying to preview things and see, make subtle lighting changes, etc., it might be a way to quickly preview what you're doing. So why do you bother rendering? Like you can turn this on here. So we're in rendered view, and you can see things that are in real time. And I suppose the answer is in Eevee, if you just want to save an image, that's why you render. Or if you want to create a movie file, so like a fly through of a scene for, say, a cutscene in a game, you'd want to export either a movie file or an image sequence that you would turn into a movie file. It's slightly different when you change render engine. So if we go into cycles, because there are things that we can do in cycles, like lighting settings and surface settings, etc., that you can't do in real time, that you have to actually process. So we can do all sorts of interesting things here, and as I wait for my computer to catch up with itself. So the kind of the rules for cycles are slightly different in that there are options available to me here that I can't see when I just use the Eevee game engine, or sorry, the Eevee render engine. Okay, so let's have a little look at what we can and can't do. So first of all, let's make an interesting shape, or maybe we'll open a file. So what have we got here? Open recent. So we'll open this guy here. So this is far from perfect. It's just playing around modeling a gun. So I'm going to turn here to render view. Now there's some textures missing that I should really replace. So the images that were in these textures are no longer have been moved, so we can't see them. So let's just delete them. So we'll select all these purple patches. Maybe we'll replace them later, but we won't worry about them for now. And yeah, and we won't bother putting extra stuff in. So that's our model there. So let's just have a little look at what how we would render, how we would get an image out of Blender that we could then use in a magazine or put on a website, etc. So first thing is we want to look through the camera. So we need a camera. So if we go to the outliner here, you can see there's all sorts of poorly labeled objects, but this is the camera here, and we need a camera. So the camera has to be in the scene. We have to position the camera so that it can see the object. So if I press N here and go to view, I have this very handy tool which is lock camera to view. So when I click that, if I hold down the middle mouse button and I rotate or I zoom, I'm actually repositioning the camera, and then I have to remember to turn it back off, and now the camera is looking from that new position. So that's a very handy tool to move the camera around the scene and get the camera to look from exactly the right angle that you're interested in. So once we have that set, then we have a couple of things that we need to investigate in terms of rendering. So let me make this the properties. I'll have a look at some of these settings. Okay, so actually I'm going to move the camera again because I'm going to play with depth of field, so we'll get look along the gun. Okay, so what sort of settings can we play with? Well, we can turn these things on: ambient occlusion, bloom, screen space reflections, and motion blur. So we'll start with motion blur. So motion blur is, as the name suggests, motion blur. So if anything's moving, it will add a blur to it, which is how we sort of perceive things in real life. If something moves very quickly, it's blurred. Screen space reflections is sort of explanatory, so it's showing you reflections on objects in real time. We'll get to depth of field in a minute. Bloom is kind of like a highlight where the light, if I maybe increase this light here, so, and then we go back here to our settings and I turn off bloom and turn it on. It's sort of it's additional sort of shine that we get from mostly from shiny surfaces with and I can do all sorts of nice things. If you have emitters, you can make them so if I select this here and I make it much stronger, and then I turn on bloom, you can see I've got sort of a blue aura that comes out beyond the actual geometry itself. So the bloom is adding additional light to the scene. And then ambient occlusion. So ambient occlusion is a very useful tool. If I turn off bloom here, I don't know if we can see it being added, but you can see there's more definition to shadows. So the darker areas get slightly darker, brighter areas get slightly brighter. You get more contrast in your image, and some of your edges and the creases and seams are more clearly defined. And so ambient occlusion is sort of like it's adding ambient light to the sort of creases and crevices in the model that you've made. Now, depth of field. Depth of field is a phenomenon that you get in when you use lenses. So not all lenses, but most lenses. So you get an area that is in focus. So this light here, I'm just going to see the name of this light here. It's called light. So we'll just call this DOF, so depth of field. And then I'm going to select my camera and turn on in the camera settings depth of field. I'm going to set the object that is going to be the center of my depth of field to be this DOF object, if I can find it anytime soon. Nope, not there yet. So let's type in DOF. Okay, so it's not letting me do that. So let's use my pipette and click that object there. There we go, light. Okay, so I didn't change its name. Very good. So when I look through the camera with depth of field turned on, this is the object that's going to be in focus. So let's go back to our camera here. So so I get to then change the settings for the depth of field. So this setting here, if I take it to sort of an extreme, if I bring it to a really low value, oh sorry, it's on f-stop here, so it's actually not so the focal distance is distance between the camera plane, so that where the sensor should be at the back of the camera, to the object. So we won't worry about that for a minute. This is what we're looking at here. So if I reduce this, you can see that only the area that is parallel with this light is in focus. If I take that light and I move it on the x-axis, so I'm going to go GX, I'm moving the area that's in focus. Now, it's quite extreme, the depth of field I'm using here, so maybe we'll make this a little bit bigger. So you can see here the handle of the gun is out of focus and the very tip is out of focus. And then I can move this down here. And it's a really handy tool to kind of draw the audience's attention in a scene to what you think is important. So as you look at this now, your eye will be driven towards the handle and the bottom of the gun, and this is sort of unimportant because it's out of focus. So it's used in, like, cinematically, if every film you've ever seen has some level of depth of field in it. It's used creatively to kind of train the audience's eye towards certain things. It's used a lot in computer games to, again, kind of direct your eye towards things that are important in the scene, and then you can move it throughout the scene, so you can change the focus. Normally it's quite subtle what you're trying to do, and you can do things called like a pull focus, or you can expand or contract the depth of field depending on what you're trying to, the look you're trying to achieve. So that's these ones here, these sort of settings, and then I've skipped over this here, which is sampling, which is basically quality. So if I set the viewport, I'm going to turn off denoising, and I'm going to set the viewport samples to be 2. Now, I don't know if you can see the drop in quality there, but as I increase the number of samples here, this is going to just look much better. And as I reduce them, the amount of detail, etc., that's visible in the viewport will be will be less. So when you're rendering, and it's more noticeable in the Cycles render engine, it's very noticeable in terms of how much noise you get. But if I turn the rendering samples down to 1 and I press F12, and that's the render I get. So you can see, there's a lot of sort of aliasing along here, along the gun. Same here along the side of this circle. So the number of samples, number of times it's looked at this image to try and get out the details, quite kind of limited. So if I increase that then, so we'll put it up at 1,000, press F12. Now, first of all, when you increase the number of samples, it's going to take a lot longer to render. So you can see now I've gone from it rendering in like less than a second to giving it 1,000 samples, and it may take 2 or 3 minutes to render. Hopefully not that long, but it could at 1,000 samples. I may have gone a little too far with that one, but this is a fast enough computer, so it should render it relatively quickly. It's not a terribly complex image. And I don't know if you can see here, I tried to move this, so basically the whole machine is locked up. It's using all the resources available to it in terms of RAM and processing until the image is complete. Would be about now that it would crash on me. Okay, so let that render away in the background. So yeah, that's far too many samples. And for this image here, we may not notice a huge difference, and we haven't saved the other one, so we haven't got a direct comparison, but there we go, it's done. So you can see this took 1 minute 13 seconds. But the elacing that we had here, or aliasing, the sort of stepping is gone. The same here on the side. If I zoom in here, so that it's a much smoother render, a much better quality render than anything that we had before. But the question is do you want to wait 1 minute per frame? And if you were doing thousands of frames to make a video or film, you wouldn't want to wait that long. So the default is 64, and that's normally enough. But that's your quality setting for how many times it's going to sample the image, and therefore, particularly things like diagonal lines will be sharper and better if you increase that number. And we can denoise, so take some of the fizz out of the viewport. Now, there are lots of other settings here for volumetrics, which is like clouds and smoke, and shadows and hair, etc. But I'm not going to look too far into now. So just going to have a basic look at rendering. So, as I said, these are our dimensions and our aspect ratios. So if we want the pixels all to be square and not to be rectangular. And then this is how many frames we're going to render. So if we go to render and we hit render animation, then it's going to render frame 1 all the way to frame 250. Now, what will it render? Well, at the moment, our output is set to be a PNG file, which is a still image. It's a particularly interesting still image because it has this RGBA option, which is to record an alpha channel. So basically a transparent background. So you could place this on top of another picture in, say, Photoshop. And how do I make the background transparent? Well, if I go back here, there's this film box. And when I unclick transparent, it will render whatever background I've made. So this is my world background here. So if I change the color of that to blue, I'll have a blue background. So, or I can put in an image, have an image in the background. So whatever I've set the background to be, it'll render, unless down here in this these settings here under film, I click transparent. And then what's in this kind of world settings here in the shader view is ignored, and it just makes it transparent. So let's go back here to our output. So at the moment we're outputting this PNG file. So we could output a JPEG if we were going to create like an image for a website, or a low quality image for kind of just general use. Then we can do quite complex and exotic forms like OpenEXR, which would be very handy if you were going to go into, say, Fusion or Nuke or something like that and do some compositing. And then we can export in movie formats, and we're quite limited in what movie formats we can use. So FFmpeg here will give us like an MP4, so MPEG-4 video. So it's very heavily compressed. The video you get is a tiny little file, like 1 or 2 megabytes. Obviously depending on your settings, but generally they're quite small, and not terribly good quality, like they're 8-bit color and stuff. Now we can export as an AVI RAW, but AVI is very, very old sort of container. So generally what people do when they're exporting out of Blender is they export image sequences. So I'll give you an example of that here. Hang on. So this is a project I've been working on. And where are my cutscenes? There's a cutscene. So let's say we go to my opening sequence and go to shot 1. So this is the shot here. So it's a guy walking up on sort of a weird kind of mountain with all spooky lights floating around him. So that's the video file of the opening shot. But what I actually exported wasn't this video file. I exported an image sequence. So each one of these images contributes to that video. So there's several hundred of them. There's 500 of them. And then in a video editing package, I took them in and I made a video out of them. Now you can actually do that in Blender if you want. Like, so this is an MP4, but in terms of quality, you're better off exporting an image sequence, and then you can work with it afterwards. The other advantage of exporting image sequences is if you're halfway through the render, let's say it's taking 3 or 4 hours, you can always just cancel the render, do something else, and then come back to it, and then just pick up at whatever frame you stopped rendering at. So if you did the first 200, then you start at 201 and render on. Whereas if you're making a movie file and you have to quit out halfway through, frequently you lose all of the rendering you've done thus far in the you don't save half the video file. So generally in this sort of work, if you're making a cutscene for a game or an animation for a film, you would export image sequences. And depending on the complexity of the project, OpenEXR is probably the best one, because it allows you to tweak things like Z depth and stuff in other bits of software. So for what we'll do, we want to transfer a cutscene into Unity. So we'll probably export a PNG sequence, and then we'll use that PNG sequence to make an MP4. So if we're playing back video in the Unity game engine, it's looking for an MP4 file. It's not looking for any other type of file format. And in fact, it won't play back many other file formats in terms of video. So we'll end up wanting our export to be an MP4. Okay, so I'm going to leave that there for now. That's 20 minutes of lots of settings. But when you're exporting your, so you have to export a still image for me. So that still image is going to have to be set here. You're going to have to put the resolution of the A4 image in here to type in your 2 numbers. And then you'll go render image. And then you're also going to create a short cutscene for me. And that will be, again, probably in HD. And then you will render the animation, which is Control F12. Okay, we'll leave it there for now.